What's good 1005 mathematicians, Mr. Herman here, and this video is looking at lesson 6 exercise 9D box plots. This will be the last lesson teaching wise for this statistics topic. For exercise 9D, the questions can be found in the year 10 textbook. And box plots, also called box and whisker plots, we use this to summarize a set of data, and specifically numerical data. If you haven't gathered yet, a lot of the last few lessons are now straying away from categorical data and more going towards numerical data, because numerical data or numbers hold significant information, and we can look at and analyze different ways and extract different information and make generalizations from numerical data. And another visual way of showing this is through a box plot. And the box plot has to do with that 5-number summary system. So the 5-number summary system that we learned in the previous video, 5-number summary system, this will be found within numerical data, so our data points, and then they will be displayed in the following way. The first thing you want to look for is your minimum and maximum values. They will be placed here and here. And then from the minimum to your Q1, this will be dictated with a line. Now these values that you are using from your data set will be put onto the bottom, and you'll just draw a line from your minimum all the way to the first digit, which is Q1, okay? Sometimes this line might be really long or really short. It just really depends on how close the minimum value in Q1 is. Once you hit Q1, between Q1 to Q3, we're going to draw our box, and this is the box component to the box plot. So from Q1 to Q3, also within here is our interquartile range. And in between that, we have to indicate where our Q2 or our median is by a line, a straight down line. This could be close to Q3, Q1, straight in the middle. Again, it really depends on the data set that you have given to you. Then from Q3 all the way to the end will be another line for our maximum value. And this is where that whisker part comes from, the whisker plot. The whisker is from Q1 to min and Q3 to max. You got to make sure that when you are creating this box plot, you got to make sure that the scale of numbers used at the bottom is consistent, okay? So it's evenly spread out, it's consistent. You don't want to say 1, 2, 3 and then skip to 10 because Q2 is 10. You want to make sure that you draw 4, 5, 6, 7, and 9 and then 10 as well, okay? So make sure that your numbers are consistent, evenly spaced. Definitely use a ruler. The other component to a box plot is an outlier. So the previous video, you know how to work out an outlier, hopefully by now. It is a bit of a lengthy process. You have to find your lower fence and your upper fence. With an outlier, once you found your lower fence and your upper fence, you worked out what they are, and then you try to see if anything's lower than the lower fence or higher than the upper fence. There we go. You will indicate the outlier by a cross. Now, sorry if you can hear some noise behind me. I've got my dog Banks kind of roaming around. She's stuck with me. You want to make sure that the outlier is marked with a cross, okay? So obviously the outlier, this right here, if we were to look at the data set, this was our maximum value. Okay, this was our maximum value. The maximum value is still the same, okay? It's still the same. However, how it's displayed on a box plot is indicated by a cross. And then where this second whisker is, from Q3 to the next value, this is the second highest value. This is the second highest value. So in essence, the maximum value doesn't necessarily change. Maximum value is still there. It's still a data point. It's still important to the information. How it's displayed, however, into a box plot is given by a cross. And this also works on the other side as well. If you have something smaller than the lower fence, you dictate it by a cross. Maybe you might have a cross here. And then the next value after the first minimum one will start here, kind of like the opposite of the high outlier. Okay, we'll look into an example of this and how to properly draw an outlier from the dataset. And one more key component is the parallel box plots. And parallel just means two lines that keep going on forever. All it just means is that there are box plots. There can be more than two. They are drawn on the same scale, and they're used to compare data sets within the same context. So sometimes you might have a data set A, and you get a bunch of numbers, and then data set B, and you get a bunch of numbers. You find your 5-number summary system for this one, 5-number summary system for this one, and then you draw two box plots side by side, dependent on what values you have. This is what a parallel box plot will look like. Okay, very, very roughly drawn. So we'll look into the first example and only example for this explanation. And we're going to construct this box plot here. We've been given this data set, and we're going to determine whether any outliers exist by first finding Q1 and Q3, and then using the equations of the lower fence and upper fence. And then we are going to draw a box plot to summarize the data, marking outliers if they exist, and the outliers are marked again just with a cross. Now for B, I'm not going to manually draw this. I'm actually just going to extract the answer straight from the textbook because it's in scale and it looks very, very neat. But for A, I will try to work this out by hand. I'm going to determine whether any outliers exist by first finding Q1 and Q3. The first thing we want to do is I want to know how many data points there are. And there's a very important step that I can do before this or after this. But for now, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So the amount of values that we have is 13, which is an odd number. So I know that there's going to be one number right in the middle, which will be our Q2. And then I have to check both sides to see if it's an even or odd tail to see what our Q1 and Q3 is. Before I even do this, you notice that this set of data is not in order. So I've got to order this. I'm going to first order this from smallest to largest. I have to. If the question hasn't done it for you, you will need to manually do this. So in order, we'll go ahead and put this in order. I'll pause it right now. All right, so I've gone ahead and ordered this from smallest to largest, making sure that there are 13 data points here. Now I've got an inkling, so this 12 looks like an outlier. I'm not too sure yet. I need to find my lower and upper fences, but specifically upper fence. For now, 13 data points. So I know that 1, 2, 3, 4, 5, 6, a 7th value here is going to be our Q2. So our Q2 is equal to 5. 1, 2, 3, 4, 5, 6 on the left. 1, 2, 3, 4, 5, 6 to the right. We now have got an even amount on one tail and an even amount on the other tail. Remember, if there's one median or Q2 in the middle, you just omit it. You just like get rid of it for now to try to work out your Q1 and Q3. You just don't get rid of it for good. It's still a data point. Our Q1, because this is even, our Q1 is the average of 3 and 4. And our Q3 is the average of 6 and 7. So Q1 is the average of 3 and 4, which is 3.5. And our Q3 is the average of 6 and 7, which is 6.5. So now we've got our values here. I'm not going to necessarily write what the minimum and maximum value is for now, just in case this 12 or even this 2 is considered an outlier. But what I can find out is what our lower and upper fence should be. So the lower fence, if you recall from the previous video, is getting Q1 and subtracting 1.5 times what the IQR is. Now, we don't know what the IQR is. We know how to get the IQR. We know that I'll put a little side note here, we know that the IQR is just Q3 take Q1, so the interquartile range, at middle range, and this is 6.5 take 3.5, which is a 3. So a middle range is 3. The middle range, the middle 50% ranges by 3 units within this data set. So all we're going to do is a straightforward substitution. Our Q1 is 3.5, and we're going to subtract, put this in brackets, 1.5 times 3. And I guess I'm expecting a negative answer, 3.5 take away. So 1.5 times 3, or 1.5 times 3. So this is 4.5, sorry. 4.5. Yeah. So 1.5 times 2 is 3, and then add another 1.5, 4.5, yep. And this ends up being negative 1. Remember, this is just a lower fence. This isn't a new data point we're going to add. This is just saying that any values that is considered less than negative 1, because it's a lower fence, is considered an outlier. Well, all of these numbers are positive. None of them are negative. So it's safe to say that there are no lower fence outliers. Okay, so 2 is considered to be a reasonable data set within the range. But what about our upper fence? So let's work out our upper fence, and let's try to find out once for all if that 12 is considered an outlier. So our upper fence is Q3 plus, because we're going higher now, plus 1.5 times the interquartile range. And straightforward substitution. Q3 is 6.5. 6.5 plus 1.5 times the IQR, which is 3. So 6.5 plus, we already worked this out here, which is 4.5. And 6.5 plus 4.5, 6 plus 4 is 10. So this is 11.5 plus 0.5. So we found our upper fence. Or in other words, anything that is, this is for lower, anything that is higher than 11 is considered an outlier. So 12 is an outlier. So right here, we've got an outlier. And remember, again, outlier just simply means a number that seems outside of the range of all the numbers here. So we worked out that middle range and figured out 1.5 times that number, and just backtracked to the lower fence and forward track to the upper fence. Now that we have this, I'm going to go ahead, pause this video, and I'm going to show you what this looks like in the form of a box plot. And here is B, guys. This is the box plot successfully drawn. We have got the minimum, which is 2, our Q1, which is 3.5, our median, which is 5, which we worked out here, which is 5, our Q3, which is 6.5, and this second tail ends at 9, because we can already figure out that 12 here was an outlier. So remember, outliers are marked as a cross, and the second highest number, the one before it, is a 9. So that tail ends at 9 from Q3 to here, 9. And that's all there is to drawing a box plot. Be mindful that the scale on the bottom here, these numbers that are spaced out, are consistent. And if you were to draw a parallel set of box plots, you would always make sure that the scale here is the same. Even if you have 2 data sets, you work out the 5-number summary system of one of them, and the other data set has their minimum value start at, say, 27. You would still have to draw that scale. It would be a very, very, very long set of numbers, but you would have to draw every single number evenly spaced out, because you're comparing the 2 set of box plots. Very rare for that to happen. You might come across it in year 11 general maths, but for now, just make sure the scale is consistent just when drawing one set of box plots, and that is it. That is all there is to it. This concludes the statistics set of lessons. The log sheet for this right here, exercise 9D, taken straight from the Year 10 textbook, page 683. Go ahead and choose what strand of questions you wish to do, upload them onto Compass, and until then guys, hopefully all these videos for the statistics statistics unit made sense. You know where I am, you guys know my email address. See you guys potentially in the next video. Catch you guys, bye.